In this case, we've got an unidentified compound and we've been told that it contains gallium and phosphorus. And we've been effectively asked to work out, well, what is the empirical formula of this unidentified compound? Right, so how am I going to approach this? So the percentage abundances, well, you know, the percentage abundances by mass, or I could call them percentage composition by mass, is given in the question. And I'm going to just do a quick check and see, well, those percentage compositions by mass, do they add up to 100 or do they add up to something else? I'm just going to quickly check that. Based on visual inspection, you can more or less figure it out, but I'm going to still do the calculation by hand, right? So 69.22 plus 30.78, right? So if you have a go at calculating that, you should find that it does add up to 100. Okay, so at this stage, I'm gonna try and figure out, well, we want the empirical formula. How are we gonna find that? So I'm gonna make an assumption, and I'm gonna say, well, to solve for that, I'm gonna need to deal with amounts of substance. But to get to amounts of substance, generally speaking, we would need to, in this case, since what we have is a percentages by mass, we would need to get the masses and then work out the moles so that we can actually compare the amounts of substance. And because of that, I'm going to assume that this is actually a sample which is specifically 100 grams total. And what that enables me to do is to effectively convert these percentages by mass into masses. And I can therefore say that the gallium, Ga, is actually 69.22 grams in this specific sample. And I can also make the assumption that the phosphorus, P, in this sample by mass is 30.78 grams. Okay. Now, from that point, what are we able to do? Well, what we need, and the equation will tell us what we need, but the moles equals mass divided by molar mass, right? So this equation is going to give us some idea of what we need. But what we need is effectively, we need to get the molar masses, right? I mean, it's clear. We've got the masses. We want the moles, we need the molar masses. And so I'm going to get that from the periodic table. And so if we go over to the periodic table, right, gallium is here and phosphorus is here, right? And what does this tell us? Well, what this effectively tells us is that these are the relative atomic masses here, so we can say that the molar mass MR of gallium is equal to 69.7, and we can say that the MR of phosphorus is equal to 31. Okay, whoa, is equal to 31. Yeah. Okay, so, and this is obviously for our purposes here, we're saying this is in grams per mole, right? Okay, so let's do the calculation, shall we? So effectively, that gets divided by the MR that we've got for gallium, and this gets divided by the MR we've got for phosphorus, right? And this effectively is going to enable us to convert these values into moles, right? And that's going to enable us to better compare them. So I would invite you at this stage to do the calculation and see what you get when you calculate these. Even before you do that, a visual inspection of these values you may notice something, right? And what you may notice is that these two numbers are quite similar, right? And here again, these two numbers are quite similar. And they're similar in a very specific way. So this value, when we look at the decimals, it's very close to, so the denominator is very close to the numerator, and it's slightly higher in value. When we look here, we notice that the 31 is similar to, it's close to the 30.78, but is slightly higher in value, right? And well, that does indicate something, but let's work it out and just to confirm our suspicion, shall we? So if you have a go at that, see what you get. And what you should find is that now we're looking at the moles. For gallium, you're going to get 0.99311, and that is going to be in a ratio to phosphorus, which is going to be 0.99290. Okay, and well, when we look at these values, you may notice something, right? You may notice something. These values are very, 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 very close to being 1, right? However, if you do happen to round them to 2 decimal places, they are not quite 1, right? Because it's not quite 1, I'm going to take one additional step and see what we get from doing that step. I'm going to determine, okay, well, the smallest value among these is the 0.99290, right? And we're going to divide, actually, I'm going to divide both of these by that value. So this is going to force one of the two numbers to become 1. And then from that point, we will be able to probably, well, let's do the calculation, right? So 0.99290, and this is also, we could divide it at 0.99290, right? So in this particular case, we don't need a supercomputer to work out what that's going to be. So this is, of course, is going to be 1 on this side. So you can, have a go on your calculator to see what you get when you work out this part, the gallium side of things. You should find that if you calculate this, you're going to get 1.00021. Okay, now when we look at both values, in contrast to what we had previously, but now when we look at both values and we say, okay, well, if we round it to 2 decimal places, in this case actually even 3 decimal places, but okay, 2 decimal places, if we round it to 2 decimal places, what are we going to get? Well, in the case of the moles corresponding with the gallium, in this case, we're going to get 1.00, right? Which is an integer value, it's a whole number. And of course on this side we're going to get still we're just going to get 1, right? And well, because of this, we can quite safely conclude that the value that would be associated with GA in this case is going to be a 1, and the value that's going to be associated with P is going to also be a 1. And on that basis, we can say, okay, well, the empirical formula in this case is going to be GAP, right? And so this is, in this case, our empirical formula. And although this is, in this case, an empirical formula, this actually this actually relates to a compound. It's called well, if we assume for a second, say, well, this is the molecular formula of an actual compound. This, one of the compounds it does relate to is gallium phosphide. So that's gallium phosphide. and so that as I just mentioned, it has effectively the formula GAP, right? And this is something that's actually used in quite a few devices. It's used in well, first of all, it would be described as a type of semiconductor, but also it's used in LEDs, right? Certain colors, orange, green as well. It's been used in LEDs for at least 50 years, basically. So for a long time, this has been used for yeah. So anyway, but yeah, this is the empirical formula GAP, and if you're interested in that compound to learn more about it, you can look that up, I guess. Yeah.